Hey, all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, the refactor video of our DICE series. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. So, where did we leave off? Well, as I was making the video on creating the code and we got to the parentheses section, I suddenly realized, there's a heck of a lot better way than just simply pushing the open and close parentheses onto the operator stack and passing a specialized close parentheses parameter to the collapse stack and having the collapse stack being able to figure out how the heck to work with the closed parentheses, or if it was not a closed parentheses. Kind of a hacky way of doing it. So once I figured that part out, I was thinking, that would make my code a heck of a lot easier. So what are we going to do? Well, basically, if you think about it, the equation between the parentheses, the open and closed parentheses, is an equation on its own. So if we conceptualize that, all we really have to do is that once we encounter an open parentheses, we just recursively call parse again on the equation. So from the program's point of view, we're sitting there thinking, all we really have to do is that if we got an open and a closed parentheses, we just have a simple equation. That's it. Since parentheses or any data within parentheses gets processed first before anything else does, we can just process the operand or the equation within the parentheses, push that result onto the operand stack, and then basically go back to whoever called it. Basically, we're going to do a recursive call. So let me just kind of go to the very top of the screen here and kind of show you what I'm looking at. Let's suppose we ended up with, or started with this equation, 1 plus 2 plus 3. Let's just make that 2 times 3. What the heck? Yeah, well, it doesn't really matter. Okay, so the idea here is that before, what I was doing, I was just pushing each character onto either the operand or the operator stack, depending upon what it was. Here's the 1 for the operand, the plus for the operator, the open parentheses will go on the operator stack, the 2 goes on, then the multiplication goes on, then the 3 goes on, then we get the closed parentheses. And then once I hit the closed parentheses, I just collapse the stack until I get to the open parentheses. And that worked out great. But it kind of made a couple little kludgy code smell type problems within the collapse stack. And what I realized is that this is one entire equation here. That's great. But if you think about it, this is another entire equation. And if we conceptualize and think about this saying, okay, we're parsing this large equation, but we can also just parse this equation all by itself before we even finish off the first one. So if we had parse recursively call itself every time we encountered an open parentheses, then we can just reuse our code over and over again until all the parentheses are taken care of. And the final result would have been basically 1 plus 6 or 7. And it will work like a champ. So the refactoring here now is, instead of going into here, like I said before, and passing, false if I have a closed parentheses and figuring out if I got closed parentheses that I'm operating, and basically, trying to figure out, if I got open parentheses or closed parentheses within the operators, what I need to do with those, when do I need to collapse the stack, and all that kind of fun stuff. Instead, all I really will have to do is, as soon as I enter a closed parentheses, I just call parse again onto the equation and let the equation parse itself out normally and treat the closed parentheses as an end of the equation. And that's a very important part here. Once I enter a closed parentheses, I will treat it as if we're at the very end of the equation, and it will parse it out as if it was its own little section. So that's going to work out great. So that's basically what we're going to do for refactoring. So I think the thing to do here is let's just get started and see what we can do. The first thing we're going to need to do here is we're going to need to figure out a way to get rid of this, which basically we've split the equation into its individual pieces as an array, and all we're doing is just shifting that data off at the beginning of the array and converting it, and we keep on going until the characters are gone. That works out great. That's no problem. But if we're going to be recursively calling parse, every time we hit a parentheses. We're not going to be able to do this. We're not going to be able to basically pass what's left of the equation into parse itself each and every single time. I mean, technically we could, but that, again, we're just going to kind of kludge it together. So when I was thinking about this, I was sitting there thinking, what would be better is if the equation parser was in some sort of service. And what I mean by a service is a code, you can almost think of it as a singleton code that is sitting out there that when any routine, whether it's parse or the collapse stack or whatever, request a character, it will go into that service and say, hey, service, give me the next character. And the service gives it the next character. So the service's responsibility is to be able to dole out the characters to whomever needs it. So whether my parse at the very beginning of the equation is calling it, or my parse 20 levels deep in parentheses is calling for the next character, there is only one instance out there that is giving us a character of the service. And that will basically solve the problem to where we may have, we're having to pass what's left of the equation from one parse to the other. That could just get kind of ugly code-wise. So let's create the service first. And the best way to do the service is to create a generator function, which will create ourselves our own iterable, that anytime we call the next method on the generator service, it will give us the next character. And that allows us to be able to deliver that same character to anybody who happens to request it. So let's take a look at some code and how that generator function will operate. Okay, the first thing I'm going to do here is since this is going to be a single service that's going to represent everything to everybody, we're going to make sure that it holds the equation and it controls what the equation is going to be. So we're going to have a place for storing the equation. We're going to have a place for storing the generator function itself, and we'll get into that here shortly on how that actually works. And the service itself will be anything that needs a character, it will call the service, and the service itself will go into the generator and say, hey, give me that next character, and then it will pass it along to whatever routine happens to call it. And that just gives us a common entry point into the service. So let's go ahead and now build this static equation. And here's our code through the magic of a cut take. So here's our generator function. And I did a boring JavaScript video on generator functions, and I'll get a link to it down below. But the idea here is that we're going to build an iterable so that any time any routine calls the next method on our generator function, it basically is asking the generator function, give me your next character. And so what will happen to the generator function is that it will, once it encounters a yield statement, this yield statement is what will be returned back to the routine that called it using the next method. And we'll show you that here very quickly, how that will operate. Now, what will happen with the generator is that once it does a yield, it actually completely stops operations. So if you notice here, I got a little for next loop, and I'm just going to, I'm sorry, that's my old basic days. I got a little for loop here that will sit there and just loop through every single length of this equation. Now you would think that basically once it executes this, it's going to give me my entire array one character at a time. That's kind of what happens, but it's not going to do it all at one time. It's going to do it just one character at a time, because once the yield statement is encountered, the execution of the function stops at that point. So the very first time I call the next method to be able to get the next character, it's going to say, okay, I is going to be equal to 0, let's yield it, and then it's going to stop. That's it, nothing else. And it will give me the first character with whatever my equation is. Then the next time I want another character, it's going to resume operations, it's going to flip back over to the for and say, okay, I is now equal to 1, let me give you the next character. And again, it'll stop at the yield. Next time through, it'll say, okay, I is now equal to 2, here's the next character, and it will stop right at that point. So every time I call next, it will grab the next character, send it on its way, and then stop execution. Finally, once there is no more data here, it's just going to flip on out. Like for instance, if we say my equation length was 5, once I is equal to 5, it's going to satisfy that it's going to basically make that equation false, and it will fall through. When it hits a return without a yield, it will automatically sit there and say, okay, my next value is undefined, but there is a done variable that is passed that says, hey, we are all now done. In fact, let me go ahead and throw that routine in here, kind of show you what's going to happen. Is I've now got a very simple routine that basically calls the next method. And whenever next is called, there's actually two properties, the value property and the done property. And done's always going to be false while there's still value, and value is going to be what we're passing back here within the yield. Once the system is done, once the equation is done, the done flag or the done property is going to be set to true, while the the value property is going to be set, in this case, to undefined. And so that's what's going to happen here. This is going to be this get next character is what all of our routines are going to call, and it's going to automatically call this next. And finally, this is what actually starts the generator up and running. When we sit there and say, okay, when we execute the generator function, that puts everything into memory and gets it all rip-roaring ready to go, and it's going to be inside the service. So when get next character calls the next, it always calls it on the service. So it doesn't call it on the generator function. The service actually holds the executed part of the generator function, and it knows what to do with that generator function. So it's a little complicated here, but the whole purpose of this is that now our parse, or any parse within our system, and this is a parse that can be called at the root, or if we had 20 different levels of parentheses, it can be called within that. It doesn't matter. It's always going to call this one singular service. So there's one place and one place only that the equations, or the characters of the equations, are sent out to our routine. So this just kind of moves all of the data delivery from parse out to a separate routine, so that now anybody could call it. So later on down the road, let's say a year from now, we've got some sort of other refactoring that needs to parse out this particular parts of the equation, then that other routine can then call the service and get the next character. Doesn't matter, anybody can. It's all now completely independent of parse, where before it was dependent upon parse, now it's completely independent. Okay, so let's take a look at parse. All right, we're not passing anything inside parse anymore. So let's take out parse. We're not going to need our characters anymore. We're going to take out that. But we are going to need to get our next character. And so how's that going to work? So let's type that in. So we let next character equal this dot get next character. That's it. So next character now contains both two values, my value property, and it contains a done property. So we're going to need to get that particular piece of we're going to need to get those pieces of information. And let's see, let's first of all set up a variable called end of the equation. End of equation equals next character dot done. And so we're going to keep on going until while not end of equation. So basically what we're done here now is we're first of all checking to make sure that we're done, and as long as we are not at the end of the equation, we're okay. So if somebody passes a blank equation in there, we're immediately going to get back out and say, because there was no yield available, we're going to immediately get out and say, hey, there's nothing there. All right, we got to get our characters. Our character before was character shift to lowercase. That's not what it is anymore. Now it's next character dot value to lowercase. Why did I not do the to lowercase up in the service? Well, because there could be times when we're working with the equation for certain functions, we may want to be case sensitive. I don't know what that could be right now, but eventually in the future we may want to be. So all the service is going to do is just, here's your character. I don't care what you want to do with it, but here's your character. Is then up to us to be able to determine what that character, what to do with that character. And for right now, we're just converting it lowercase. We may not do that later. But the whole idea of the service is we're not going to do anything to the characters on the service. Its sole responsibility is to deliver data. That's it. What we do with the data is our responsibility. So now we've got the character. And none of this other data should change at all, because the whole idea here is that all of this that we've been working with here is basically working on the character, so that's fine. So actually the very final thing we need to do is way down here at the bottom, at the very end. Make sure is that the end? So that's line 99. Yep. Okay, so that's the end. So just before the very end, we're going to need to get our next character. So we'll say next character equals this dot get next character. Oops, and then one more thing, I forgot. End of equation equals next character dot done. And the reason we have, obviously the reason we have to do that is because our loop is for end of the equation. So once we get the next character, we then set our end of equation flag to equal the done flag. And that should be it. Next character is getting up there. Okay, that's no problem here. All that is again, we're working on the characters. There's return the operand 0. Nothing we're going to have to change in the close stack. Nothing have to change in the collapse. You know, technically that should be it. That should be everything we need to do to implement our service, which will now completely take out. Let me just take all that out. I don't like that sitting there. This will basically now need to be all we need to do to have our parser, our equation data sender, if you want to put it that way, is into a service. That should be it. So technically, our test should now run exactly the same. And this is the whole idea behind refactoring. We've refactored it to make the code a little bit better, although it seems a little bit more complicated now. Honestly, once we get the recursive calling of the parsing done, you'll see how important it is to have done what we just got finished doing. But this should now run just the same before. Let's find out. I'll see you on the other side. And we're done, and there we are. Hey, all the tests still pass, so that means we've now been able to successfully take the parsing of the equation, or sorry, the delivery of the data within the equation out of the parse method and put it in its own separate service. Now that we have gotten our service ready to go, let's take a look at our parsing and making sure that our parsing can be called recursively. So the real key here is that whenever we call the open parentheses, we're going to be wanting to do something like this. Operands.push this dot parse. Basically that. So instead of pushing the actual character as we did before, we're going to push the results of parse, because parse is always going to return the 0th operand, 0th, the very first element within the, or the first first element within the operand. So by doing that, we're going to now push it onto the operand stack from the parent operand stack. So this is basically how we're going to want to call everything recursively. So how do we know that we've now finished off the, how do we know that we have finished off the parentheses? Well, that's going to be the right parentheses. So the right parentheses is basically going to have to, let me just take a look here. The right parentheses is basically going to have to collapse the stack itself. So all it needs to do is just this line right here. Now we got the closed parentheses trap there. We're really not going to need that anymore, since we're considering that the closed parentheses is going to end the equation. So let's get rid of that. We really don't need this anymore. And we're not going to need to pop the operator off the stack because we have no operator. So this is actually much better code. If we're going to push the results of the parse, when we're within the parse itself, we're going to collapse the right parenthesis. Well, the right parenthesis is going to tell us that we need to completely collapse the stack, that we're done with the particular equation. All right, so technically that's all that really should be needed to do. Now that means we're going to pass, I'm not going to worry about fixing this down here because we're not passing, well, actually let's go ahead and fix that. We're not passing closed parentheses anymore. So we're not going to need this anymore because that's while it's not equal to closed parentheses. We're not going to need this anymore. So that makes it a heck of a lot easier at that point. So would technically that work? Well, let's kind of just think through it here. If we just had 1 plus 2, 1 plus 2 plus, or 1 plus open parentheses 2 plus 3, the 1 and the 2 when we open, are going to be fine. The 1 and the plus are going to be fine. When we open up the parentheses, we're going to push a new parse. So we're next going to go back to parse again, and parse is going to create a new operand and a new operator stack, completely blank, because we're now we've now recursively called parse. We're going to get the next character. This is why we've done the service now, is that we're now, if there's only one person who's delivering the service, not only is the first parser getting characters, but now the second one is too. So that's the reason that we took the parsing of the equation outside of parse, or I'm sorry, the getting the next character out of the equation outside of parse, because by doing that, any number of parses can now call it. So our second parse is calling the get next character. That's going to be the number 1. So it's going to push it onto the operator. Number 2. So it's push on the operator stack. Then we'll get the next character. That's going to be the plus sign. So it's going to push to the operator. Then we're going to get the next character, which is going to be the number 3. So that's going to be pushed onto the number. Then we're going to get the right parentheses. So the right parentheses is going to collapse the stack. So that's going to call collapse the stack, and it doesn't really matter. It's going to collapse the stack while the operators are at length. Now remember, we're in the second parsing, and it only has two operands, the 2 and the 3, and the operator of plus. So this should work out perfectly okay. We should end up with basically the number 5 in this case. So we get the number 5. So it returns, so basically number 5 is now on the operand stack. So the number 5 is on the operand stack. We break, and then we get the next character, which is into the equation nothing. We get the next character, which is a nothing equation, which is absolutely nothing. So we're pretty much done at that point. But do you realize there's an error here? Aha. Yes, there is, because think about it. What if we had 1 plus open parentheses, 2 plus 3 close parentheses plus 4? We're going to get a plus here, and we're going to start doing the plus sign. We're still in the second parsing. According to our theory here is that everything within the set of parentheses is one equation that we're going to process. So we're actually finished with the equation 2 plus 3. There should be nothing else to parse. But we're now saying, hey, we don't get you the next character, which is another plus. That's not going to work. So we've got to be able to take that into consideration. And the easiest way to do that is that saying that, hey, when we do enter in a greater than sign, or I'm sorry, an open parenthesis sign, we're actually at the end of the equation. There is nothing else to get. So we're going to say end of equation equals true. Because we're going to basically have to tell the system that, hey, we are now completely at the end of the equation. There is nothing left to parse. So that when we get down here, because we're at a surface, if we are not at the end of the equation, then we can do the next character. But if we are at the end of the equation, which we are at a closed parentheses, the right-hand side parentheses, then we don't need to get the next character, because that next character belongs to its parent parse, not our current one. So that should work. So we now got the number. Number's going to be blank, so it's no big deal. Because remember, we're on the second parse now. This is going to collapse the stack, which is, again, no big deal. Same error will occur, and we're going to return the operand, which is the first operand. So that's great. So we've now returned the first operand. That's going to push that to the operand stack. So it's going to push number 5 to the operand stack. So what does the parent parse has now? The parent parse has the 1 and the 5 on the operand stack and a plus on the operator. It's going to then go through, get the next character, because remember, end of the equation is now false because we're back into the parent. So it's going to get the end of the equation, and it's going to say next character. And once it gets the next character, it's going to say, yep, there's no more characters, so end of equation is done. So it's going to go through all this. It's going to collapse the stack. That will give us a number of 6. It's going to return operand 0, and it should work at that point. So that should be it. Let's find out. Let's run our test. npm run test e2e ci. I'll see you on the other side. Okay, we're done, and we still have one error on the parentheses. Let's take a look and see what it is. Alrighty. And it's a mismatch. Should throw error if more closed than open. And notice it says assertion error. The actual error is expected assertion error to equal error. How is that going to happen? Well, let's go to our code here, parentheses test code, and let's see. Here's the code down here. Should throw error if more closed than open. So if it actually if the actual error is expected assertion error to equal error, that means this is what got thrown. Line number 48, which means it accepted this as a completely legal equation. Well, let's figure out what happened there. So it's 3 plus 4 and 2 close parentheses. So let's figure that out. Let's go up here, our little scratch pad here. And so our equation was 3 plus 4 with 2 close parentheses. Sorry, so what's going to happen is that the root is going to sit there and figure out, okay, the first root is going to go open the close parentheses. So it's actually going to go in, this is our first root. So it's actually going to go into our first parse, excuse me. That's going to go into our second parse. And our second parse is going to say, okay, we're at 3 plus 4. And then we get the close parentheses. And close parentheses says, oh, all right, we're at the end of this equation. Let's figure it out. So it's going to figure out the 3 plus 4 is equal to 7. So what's going to happen is that's now going to that's going to finish up. That parse is going to finish up, and that parse will be pushed onto the operand stack. And so back at number 1 here, our operand stack is going to have 3 plus 4 is equal to 7. So what's the next character? We're not done yet, because the next character is another open parentheses. Excuse me, close parentheses. So we come down here. Our next character is close parentheses. We loop back up. Are we at the end of the equation? Nope. All right. Next character is close parentheses. Blah, 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 blah. We get to the close parentheses. And where's my close parentheses? All right. We collapse the stack. Well, the stack's already collapsed. There's just the number 7 on it, so there's no big deal. We're at the end of the equation is equal to true. Okay, so if we're at the end of the equation, we are. So therefore, we don't do anything. We come back up here. Are we at the end of the equation? We sure are. So we come back to the number. We do an operand push. And therefore, we collapse stack, nothing on it, it's just number 7, so we return operand 0. So it eventually gets back up to here and returns the number 7. But isn't that what we wanted? Well, yeah, but think about it. Basically, this last close parentheses was completely ignored. We could have had 100 close parentheses at the very end here, and they all would have been completely ignored. And that's just not right. So our biggest problem now we're going to have to try to figure out here is that, well, what are we going to do here? Is that we can't have a whole bunch of close parentheses. Well, the only place we're going to find those close parentheses is if we're on the very first parse, not all of the subsequent recursive callings of the parsing. So what I would propose to do here is that since each parse has its own operand and operator, let's now extract that back into its own class. And that own class will basically be called a stack class. And the stack class will have basically 3 variables in it. You'll have an operand array, an operator array, and it will have a flag called root. And this flag called root will either say that I'm at the very root or the very first parsing, or I'm not at the very first parsing. And so we could use that root to be able to determine, hey, if we encounter a close parentheses and we are on the root, that means that we've got extra close parentheses out there, and so that just isn't going to work. So let's get to it. Let's throw some code in there. And there's our first code. It's extraordinarily simple. We've got public properties called operands, operators, and root. And I'm not exporting this class, so this class is just available to this particular dice. It's basically, it's almost like a private class almost, basically. The constructor is very easy. I'm just constructing by default an operand, an operator, and a root is equal to true. So if we pass a root is equal to false, we're just going to say true or false for root. And that's really the most important thing here, is that the root is either, we need to know whether we are at the very root or the very first parsing, or we're at subsequent parsings or subsequent children's of those parsings. So let's now get our code all nice and pretty here. All right, so we don't have this anymore. Let operators and operands. That is now going to be changed to, should we do, yeah, we'll do a constant, I think, there. Nope, I think we need to do a stack. Let's just call it stack. That'd be the easiest thing. New stack. And we're going to have to pass it a root, because remember, we're calling parse out each and every single time. So we're going to have to, when we ever call parse, we're going to have to call something in there that basically says, you know, am I parsing it at the root or am I not? So parse now is going to have a root that, or a argument here that is either going to be true or it's going to be false. And this will allow us to be able to sit here and say, you know, hey, this particular route is going to be the first parsing, or it's going to be the last parsing. So now we've got to go back up to here where we first called parse, and we're going to make that true. Then we're going to come back. The only other place we call parse is when we have an open parentheses. We're going to call parse there and make that false. This basically signify that, hey, we are on a child parsing, for lack of a better term. So that should fix those two particular things right there. So now we've got a new stack. We don't have the operator or the operand. And so now, obviously, we got errors all over the place because we've been dealing with operators and operands. So all we really have to do now is just prefix this with stack. Okay. So now instead of just calling straight operands, we're now doing stack.operands. Same thing with operators down here. Stack. Now we just have to kind of go through same thing right here. Stack. Now, collapse stack, notice we're passing operators and operands into collapse stack, but actually we now have a class that handles all that, so why don't we just pass the class itself? Or the class instance, actually. So now we're just going to pass the class instance into the stack. And in fact, well, we'll get to that a little bit later. So that should be the same. Index of operators, that will now be stack.operators. That'll be stack.operators. That will be stack.operands. And well, we really can't do that because we're doing a collapse stack here. Let's go ahead and clear this out real quick. Because we're doing a collapse stack here where you really can't return the operators and operands. So why don't we have collapse stack return a stack? So we'll just return itself back in. We'll fix that here in a second. Well, now we're doing it down there. Let's do it up here too. And in reality, that's really not necessary because as you'll see here in a second, we'll get to that in just a minute. Okay, operators is illegal, so let's put stack.operators. Here we are doing saving the information from the collapse stack, so it's going to be stack equals collapse stack stack. All right. Operators is illegal, so let's put stack.operators there, and then we're done. End of equation, that should be fine. Oh, this is illegal down here. So let's put stack.dot there. Here we got the, again, we got the collapse stack problem. So let's do a collapse stack. And change that to stack. Whoa! I hit the wrong key. What happened? Where did I go? Where am I? There we go. Yeah. I hate when that happens. Okay, operands.length. That's now going to be stack.operands.length and stack.operators.length. And we're going to return stack.operands at 0. Cool. All right, collapse stack now returns a stack. So instead of returning operands and operators, it's going to return stack. Okay. Instead of saying stacks, because it's now just a simple stack, we're going to take that. In fact, we can now take that out, and we can do stack.operators length. And same thing we can here. So it looks like collapse is going to also have to return stack. So we'll pass stack to operators, and we'll have it return stack. All right. So that's cool there. Yeah. So now that code. Here I'd like to have a regex to get what I need. Well, I don't need that anymore because it's extraordinarily simple now. We just do a simple little loop. So now we did the collapse stacks. We take that off. Don't need this anymore. Okay, operands.length is now, oh, I must have accidentally hit the wrong copy. All right, here we go, stack dot. So that's now stack.operands, that's stack.operators. Let's see, that's going to be stack.operands, stack.operators, return operands operators. We're not going to do that. We're going to return stack. All right, we're going to stack.operators length there. Operators pop. We're going to do stack.operators. You can see what we're doing here. Just kind of going through the whole thing here. There's operands.length. Will that be stacks? Operands.length. Luckily, my ID, there's a little squirrely line underneath it so I can know exactly what I need to change. Stacks.operands. 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 That might be it. Nope, two more down here. Operands.push, and we're returning stack. Now I know what you're saying. Couldn't we have just sit there and said at the very top here, constant operands, operators equals stack, and not have to change all that? Absolutely, we could have done that. In fact, we don't even have to return stack because these are going to be passed as, everything's going to be passed around as references. So we don't even have to return stack. Stack would have been mutated anyway. The only reason I did it the way I've done it here is just kind of for completeness, to show you everything that's happening. To show you the only reason I did this is for completeness, to show you everything that is happening with the stack itself. This is actually, yeah, we could have easily just done stack, operators and operands and fixed up all of that. And we don't have to return stack at all. We could have just gone blank because everything's passed as references here. Same thing here, everything is passed as references. Same thing up here, everything is passed as references. So no, we didn't have to sit there and do stack.operators, stack.operands. We could have pretty much just done one line of code at the top and kept it the way we had it. But again, this is just, a lot of this I'm creating here is for educational purposes. So this is just something to kind of show you, a complete code. Could it be better? Sure. But at least this way you know exactly what's going on. So what's our result here now? Now that we've got this class that has its own, I like semicolons. Let's put the semicolon. Actually, I don't need a semicolon there. So we got stack. That's our class. It contains the operands, the operators, and the root. When we first call parse for the absolute very first time, which is on our roll, then we pass it as true, saying, hey, this is the very first time we're calling parse. Any subsequent time we call parse, which only occurs when we have an open parentheses, we're going to pass it false. And in that particular way, now with the closed parentheses, we can very easily check to make sure that we are on the root or not. Because if we enter, if we get a closed parentheses that is not, that is on the root, then we got a mismatch of parentheses. We have too many closed parentheses. If we're outside of a root, then that closed parentheses is a legal one. Because you got to remember, with the closed parentheses, the only time we're going to have a mismatch of closed parentheses is if we finally get to the very root or the very first parse and we have some closed parentheses left. So this is all we have to check for. Once we have that checked, that should clear our particular error. Let's see. Let's clear off the screen. Let's run it. I'll see you on the other side. And we're finished up, and yep, everything has now passed. So now we know that all the refactoring we did with both the service for the equations and for the custom class, specifically for doing a recursive on the parsing, now passes all our tests. So our DICE program, while technically a little larger, is now much easier to understand if somebody else was to come in here. This code that we're working with on the greater than, on the, excuse me, the open and closed parentheses is much easier to understand. This collapse stack has gotten much smaller. All of this is just a great deal easier now to understand. And now that we have the stat class, we can now add to it later on without having to sit there and mess up any of our code. And now we also have this service here. If we happen to have any other routines that may happen to call getNextCharacter, they can call getNextCharacter to their heart's content, and it's not going to mess up anybody else. So that should complete, in fact it doesn't should, it does complete our first refactoring of our DICE class to make things work a lot easier than it did before. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. And again, thanks for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.